Hello everyone, here we are going to start the first part of our three-part lecture as the third chapter of REMEDI module. And the main idea here is to discuss the application of machine learning in environmental sciences. Here we go. So, in this lightning course, we are going to explore the application of machine learning techniques in environmental sciences. And our main focus will be on contaminant remediation. Students, audience, researchers will gain a general understanding of how machine learning can be used to analyze, model, and predict the behavior of these pollutants in subsurface flow, rivers, and in general, in a broader idea, in environment. As the first step, we need to understand what is the definition of machine learning. Machine learning is a subset of broader idea called artificial intelligence technology that enables computer systems to learn and improve without being explicitly programmed. Instead, these computer systems use algorithms to analyze data, recognize patterns, and make decisions. How is machine learning used in environmental sciences? Historically speaking, we can say that since 20 years ago, hydrologists, atmospheric scientists, ecologists, hydrogeologists, and in a general term, environmental scientists have started to exploit the benefits of machine learning in their research areas. So they understood that it has a potential, enormous potential, to unlock new insights in environmental sciences. For atmospheric scientists people, it can be used to analyze satellite imagery and predict changes and anomalies in weather patterns. For hydrogeologists, it can be used to identify, measure soil moisture, and even identify microscopic organisms. So it's quite important. Why is machine learning important though? Machine learning offers significant advantages over traditional methods, for example, numerical methods. We, as a researcher, probably have used finite difference methods, finite element methods. So compared to those methods in environmental science, machine learning can give us more advantages because it can analyze vast amounts of data quickly and accurately. It can also learn from new data in real time, continually improving its insights and predictions. But why is machine learning? Learning is any process by which a system improves performance from experience. And I've quoted Herbert Simon. This is actually what's going on in the life as well. We try several things and we gain experiences and we learn based on them. Definition by Tom Mitchell. Machine learning is the study of algorithms that can improve their performance, which is recalled by the term P, at some risk, that we call it T, with experience that we denote it by E. So a well-defined learning task is given by the combination of performance, the task that is under study, and the experience that we are gaining in that experience, in that task. So let's delve into a bit of detail of soil and river pollution remediation. So as we know, soil pollution is a major environmental challenge and can cause significant health risks and environmental damages. It can be caused by several factors, such as heavy metals, pesticides, fertilizers, and chemicals used in agriculture, industrial production, and also urbanization. River pollution is a widespread problem and have several implications for water quality, plant and animal life, and also human health. Sources of these pollutions are also similar to what polluting in the soil as well, such as industrial and agricultural waste, sewage, and oil spills. The challenges that we have faced so far in the area of pollution remediation are several factors. Here we are only mentioning two of them. The first one, limitations of chemical remediation. Traditional methods of soil and river pollution remediation rely heavily on the use of chemicals, which can be costly and by themselves pose significant risks to human and environmental health. I'm giving you an example. We know that to clean the water, we are using chloride, but above a threshold, a known threshold, we know that chloride can be toxic to the human health. The second factor, limited capacity of physical removal techniques. Physical methods of pollution remediation, like dredging and excavation, can be costly and time-consuming. They also often fail to address the root causes of pollution and only offer temporary solutions. So, what can machine learning do for us in the area of pollution remediation? First, real-time monitoring of pollution sources. Machine learning can be used to build sophisticated monitoring systems to detect contaminants, pollutants at their sources. This is very important. It can also help identify potential pollution sources before they cause significant environmental damage. So, in other terms, if we stop something from getting spread over a larger domain, that's much better. As an example, we have faced with a human health crisis called COVID-19, and we had to stop it using vaccination. And we knew that if we let the virus spread over a larger population, it can cause more casualties. And this is unfortunately what happened over the last 3 or 4 years. And still, it's continuing. But after vaccination, at least we are facing it with a general and less risky, let it put like this, less risky sickness. The second area that machine learning can help us in contaminant remediation can be prediction and early warning systems. Using machine learning, environmental scientists could build early warning systems that can predict the spread of contamination in soil and water, allowing for a more targeted and efficient remediation effort. So without wasting the money, time, if we know exactly where and when the problem happened, of course, we have a better idea of how we can approach the problem. This is a rule of thumb. And the third area that machine learning can help us is optimizing cleanup strategies. Machine learning can analyze data on different remediation methods and predict their effectiveness, helping to create more efficient and cost-effective remediation strategies. Let me give you some examples of some case studies that I have found online of successful application of machine learning targeting the pollution. Soil pollution that happened in Exxon Valdez. After the Exxon Valdez oil spill in 1989, people have used probably the classical versions, older versions of machine learning was used to detect and analyze oil spill and cleanup efforts in real time, leading to more effective and efficient cleanup efforts. Another example can be Lake Erie, that machine learning was used by researchers and scientists to analyze weather data and predict the spread of harmful algal blooms in Lake Erie, helping to prevent the outright shutdown of waterways and improving water quality before it spread over a larger domain. Another example can be the London's air quality. We all know that in London, let's say that over 20 years ago, we had a very severe condition in air quality. So researchers have used machine learning to analyze the air quality data in London, to develop targeted pollution reduction strategies leading to a significant reduction in air pollution and improvements in public health. So, future potential and limitations of machine learning in environmental sciences. So if we are going to use some tool, we need to understand and don't over-expect the benefits of this tool in order to exploit the maximum potential for autonomous environmental monitoring. As we discussed, machine learning has the potential to enable ground and air-based sensors to be autonomically gathering environmental data and forecast changes in environmental trends. And we gave you an example on the reduce climate change. Challenges in data collection and interpretation of the data. Machine learning models are highly dependent on the quality and accuracy of the data that they are trained on. Compromised data create biases that can hinder the effectiveness of these systems in environmental monitoring. Limitations of predictive analysis. While machine learning can offer significant advantages in predicting environmental conditions, it is equally critical to consider human factors that might not be captured by these models. Conclusion and future directions. So, machine learning holds great promise for environmental sciences. Machine learning offers new ways to address environmental challenges, from soil pollution and river pollution remediation to climate change research and natural resources management. Still, we need to put more effort in this area. Future research is required. Despite the many successes of machine learning and environmental science, there is still a long road ahead to fully incorporate its potential in our research fields. A continuous focus on research is still required to harness the promise of these newly developed technologies. So, as a take-home message and the last slide of the first part of the chapter 3 of the REMEDI module, we can say that machine learning is used when human expertise doesn't exist or partially exist. So, with this, we are ending the first part of our chapter 3 of the REMEDI module. Hope it was useful for you.